Alright, Halloween is coming up, so we are going to take a moment to appreciate a Halloween comic. So as you can see in this frame, the skeleton says to the vampire, "Hey, what are you doing? Looking for your next victim, huh?" Do you get it? Because vampires bite people in the neck, so next victim, like next victim. Wordplay. It's great. Alright, your frame looks like this, and we are combining like terms today. So, combining like terms is about adding and subtracting terms of expressions that have the same variable parts. Okay, let's talk about that a little bit more, what like terms are. Alright, like terms are terms in an expression that have the same variable parts. Alright, so let's just do some examples. So these are like terms, like 2x. The variable part here is x, so anything that has an x in the end of it, like 10x, those are like terms. That means we can combine them, or negative 15x. Okay, so that x is a variable part. All of these have the same variable part. Like another example of like terms would be like 3mn. The variable part here is mn, m times n. So another example would be 6mn or negative mn. Because remember, there's really a negative 1 in front of that. So mn was the variable part there. Alright, another like terms would be 5. There's no variable part here, so anything that doesn't have a variable part would be a like term of it. So like 5, negative 6, 17, 500, just like any normal number that we always combine, that we always add together or subtract. Okay, unlike terms, just so that we're clear, 3x. Okay, that has the variable part of x. An unlike term of 3x would be 4xy. Okay, even though that there's an x that's the same, there's an x in both of them, this one only has x. This is x times y. That's completely different. Not completely different, but it's different. It's not exactly alike. Another number that would be, or another term that would not be like, that is unlike, would be 5 times x squared. Okay, even though again it has that x in it, because it's x times x or x squared, it becomes unlike. You cannot combine it. Okay, because if this x was a 2 is not like a 4. It's not the same thing, okay? So you gotta keep that in mind when we combine these like terms. It has to look like the variable part has to be exactly the same when you combine them. Okay, so we're gonna go to our first example after going through the steps. Our first step is to change subtracting to adding the opposite. Then we need to identify like terms with shapes or colors, and then combine like terms by using algebraic properties and their coefficients. So first thing we need to do here is change this subtracting to adding the opposite. Okay, and notice in all of our examples we're just dealing with all adding or some adding and some subtracting that we can change to all adding. Alright, we're going to identify our like terms. Here we have a 7r. I'm going to put a box around it. And that's 7r, that variable part is r. Is there anything else in this expression that has a variable part of r? Well, r does. Okay. Then we have a 7. Is there anything, this one has no variable part. Is there another term of the coefficient that has no variable part? The negative 6. Okay. So we're going to rewrite it using the commutative property of addition. So we're on that third step now. Combine like terms by using algebraic properties and coefficients. So we're going to rearrange it. We're going to want the purple by the purple and the red by the red. So 7r plus r plus 7 plus negative 6. That commutative property means that we can put it in any order we want to. Alright, we also have to use the associative property, or the A property of addition. Because we want to group 7r, we want to group those like terms together. Okay, now we can actually add them. So 7r plus r, this is like taking 7 r's. 1, 2, 3, 4, 5, 6, 7, and adding one more r. How many r's are there now? Well, there's 8. So we get 8r plus, over here we have 7 plus negative 6. Well, 7 minus 6 is 1. So we get 8r plus 1 is our final answer. Alright, so first we color-coded it. The next one we'll do by, well, first we added the opposite, then we color-coded it. Use the commutative property of addition and the associative property of addition to combine those like terms. We did 7r plus r is 8r. 7 plus negative 6 is 1. Alright, let's go on to the next one. Alright, here we need to change subtracting to adding the opposite. So again, here we have subtracting. We're going to change that to adding the opposite. Then we're going to identify like terms with shapes or colors. This time we'll do shapes. Okay, so we have 12a. I'm going to put a box around that one. And we have 12a. I'm going to put a box around that one. We have 19b. I'm going to put a circle around it. And negative 9b. Put a circle around it. We're going to then want to use our algebraic properties. So first I'm going to use the commutative property of addition to rewrite it. So I'm going to put the boxes together and the circles together. You want the like terms right next to each other. 12a plus 12a plus 19b plus negative 9b. We also want to use the associative property, or the A property of addition, because we want to group those together. We want to do 12a plus 12a and 19b plus negative 9b. And that's because if we just did 12a plus 12a, we can't combine these without saying we need to put them in grouping symbols and saying, yep, we can. Oh, I forgot my b here. Sorry, there's a b. Alright, so 12a plus 12a, that's taking 12a's and adding another 12a's. So really all you're doing is adding the coefficients. 12 plus 12 is 24. So we get 24a plus 19b plus negative 9b. So you have 19b's, you're taking 9 of them away. So 19 minus 9 is 10b, or 19 plus negative 9. So we get 24a plus 10b. And we cannot combine those any further because we don't know what a is yet and we don't know what b is yet. Alright, let's go to the last example. This time, well, first we got to change the adding to subtracting to adding the opposite. So here's the subtracting sign. We're going to change that to adding a negative 2x. And here's another one, so we're going to change that to adding a negative 3x. I'm going to both color code them and put them in different shapes. So for those of you that, depending on what you like to do, you can do both or either one. So here's 6xy. I'm going to put it in red. And 2xy. They have the same variable part. So I'm putting them in circles and in red. I'm going to put the negative 2x in a box. The variable part is just x. So here's the other like term. It's just the x. Alright, the last one we have is 5x squared. That one's kind of all by itself, so I'm going to put in this squiggly circle. Okay, so we're going to use the commutative property first of addition. To arrange our like terms so they're near each other. So 6xy plus 2xy plus negative 2x plus negative 3x plus 5x squared. Alright, then we are going to use, we're going to then use the associative property, or the A property of addition. Alright, so we have 6xy plus 2xy in parentheses because we want to do that first, while also having to do negative 2x plus negative 3x in parentheses, plus, and then 5x squared can stay outside of parentheses because we can't combine that with anything yet because we don't know what the x is. Alright, then we actually combine them. We can use the coefficients this time. We have 6xy's plus 2 more xy's. So we get 8xy plus negative 2x plus negative 3x. We're going to get negative 5x plus 5x squared. All the variable parts are different. We have an xy, an x, and an x squared. Even though they all contain an x, they're too different that we cannot combine anymore. So this is our final answer. Alright, so there. So what? Remember your algebraic properties and spelling this wrong. Sorry. Remember algebraic properties and always, again, this is so important, always change subtracting where did my pen go? Disappeared. Always change subtracting to adding the opposite. I don't know what happened to my pen. So you're going to have to write that down. Always change subtracting to adding the opposite. There you go. Okay, reminder. Take the quiz. Do it. Okay, bye.